There it is. Okay. So let's start that whole thing again. My bad. No, what happened was I have to turn this mic off during like those intro scenes so that things don't get totally messed up. So that you can't hear me like breathing and being nervous and whatnot. So that's what happened. So I apologize for that. Anyway, like I was saying, this week we were sponsored by Multirotor Mania. We have two streams coming up with Multirotor Mania, and we have then a couple videos after that are going to be published in the next few weeks. But anyway, but today's live stream is all about OSD setup and configuration. We've got two different OSDs from Multirotor Mania. We have their FTDI adapter and their flight controller and a whole bunch of stuff, and we're going to be setting all that up and getting an OSD configured, and we're going to talk through kind of my pros and cons of OSDs. And for those of you that have kind of been around and know me talk about it, I always say no SD is the best OSD, but I think I'm changing my mind on that, and we'll talk a little bit about why. Let's see. We'll go ahead and get started by looking through some of these parts, see what we're going to be working on, and then just jump right into it. Once again, if you're new tonight, it's super exciting to have you here. We do this every week at 8 o'clock Eastern time. That's 5 p.m. Pacific time, and that's just kind of the most convenient time, I think, for both me and everyone across the United States. And everything will be uploaded tomorrow, so you can come back and watch this whole thing yourself. So if you're not catching it live, you're going to be able to see it later. Now, if you are a first-timer, super excited that you're here. If you're coming back, I'm sorry that you don't have something better to do on a Thursday night. And if you're a sponsor, I'm really excited about talking about doing other streams like this. So thank you so much for coming out, and I am glad that you're here. We also have a promo code for this live stream that will allow you to get free shipping from Multirotor Mania on in any cart that has an FTDI adapter purchased with it. I was working with Multirotor Mania to find the best possible price point for that, and this kind of seemed to be the best option. But these are priced to win, and they're priced to go. It's a fantastic deal. So I suggest that if you're interested at all in trying out an FPV OSD system, you will want to use the promo code BulbufetFPV to sign up. I'll write it down here in a second so that you can see it. But yeah, so that's that. Yeah, be pretty excited. Boba Fett FPV, multirotormania.com has put it in the sidebar. I'm also going to put it here on the table. All right, so let's get into it. I'm going to switch over to my USB camera. You can now see my desktop, and we're going to go over some of these parts. So BULBUFET, and that's not showing up at all. Oh, just kidding. FPV. That's a lowercase b. Should have been better prepared on that. Can you even see that? BULBUFET FPV for a free order, free shipping on any order where you purchase an FTDI adapter or OSD. Okay, so that's the promo code. That's going to be live for 24 hours. So you have until tomorrow at midnight to pick up your kit. But so let's talk about what we got here. So we're talking about OSDs. We have two different OSDs that we're going to look at. We're only going to assemble one. And that is, hold on, where's my other one? That is the Micro Minim OSD. That's this one here in the package. This is the Micro Minim OSD, and this is the Minim OSD. Multirotor Mania sells both of them on their site, and they're both a great deal. They're like 10, 11, 12 bucks. I can't remember exactly right off the top of my head. So this is the Minim OSD. This is the Micro Minim OSD right here. Let me zoom this in a little bit so you can actually see it. They're tiny. So this guy, this is an interesting fact that I learned about it, and we're not going to build it because it's so tiny and just it's a little bit hard to work with, especially on camera, but it's a great setup. But one interesting fact about it is that it's actually smaller than the back of an HS1177 FPV camera. And so you can actually assemble it, put it on the camera, and then have a camera and OSD all in one. On the other hand, this guy is the Minim OSD, and it's a little bit easier to work with, in my opinion, just because it's bigger pads, a little bit better wiring diagram. So I've got Multirotor Mania also sent out wiring diagrams for both of these, which is great. So you can kind of see how to set everything up as you go. Now, what are the features on these things? So I'm gonna set this one aside for now. We can talk about it more later if we want, but they both have the same features, just kind of separated into two different layouts. One, this one being a little bit more convenient for a live stream, and for you could use it for bigger builds. And then this one is a little bit smaller, lighter. It's going to be harder to work with, but you're going to have all of the same features as the big one. I think there's things like those push button and stuff that are different. But so what you've got here, and we'll kind of go down the list, go down the things here. On this side, this is your FTDI connection. So this is how you're going to connect to it with USB and use. I see a lot of people complaining about the frame rate. How bad is it? Like I'm having my computer's going a little bit slow, to be honest, and I'm wondering if that's having part of the problem, but it's sorry. So we have this. So this is all the FTDI components, and we're actually going to put a set of pin headers in there so that we can get in and out and change settings as quickly as possible. All right. Next, we have along this side, we have input for what's called an FPV battery. We have input for what's called a main battery. And then we have signal RSSI and signal current sensor. So in these two ports over here, you can put in a voltage it basically acts as a voltage center. So you can plug in directly to your LiPo so that you see the voltage of the LiPo on the OSD. You can either run that through your flight controller or through the OSD, but I prefer to do it through the OSD so that you get a more consistent, it's all wired in the same place. You don't have to think about extra settings. I'm just gonna fiddle with for a second with settings here to see if I can get that frame rate to increase a little bit. Give me just a second. Does anybody have any questions before we get started here that I can answer? I'm watching the chat here at the same time. Let me know if this gets any better. Bum, ba-dum, bum. This is exciting. Okay, let's try this. So let me know if this improves it at all. But yeah, let me know. So, okay, back to where we're going. So you can hook up an FPV battery, which is for bigger systems where they have a separate battery for FPV and for flight battery. And the reason that you would do that is because if your flight battery dies, you could still see your FPV, you could see your GPS coordinates, and kind of know where your craft went down if you needed to. And so you can put voltage sensors on both of those. But we're flying little racing quads, so we probably don't need to worry about that too much today. The main battery is the same thing, but for the flight battery. The RSSI signal allows you to feed RSSI back off of your receiver and plug it into a and see what your signal strength is directly on your OSD. You can also run that through the flight controller, which we'll talk about a little bit later. Finally, you also have the ability to plug in a current sensor, which will calculate the actual amount of milliamps used off of your battery, so that you can you don't have to just go off of voltage, which changes based on how much throttle you're using or whatever. But you'll be able to get a lot going with that. So, but you need an external current sensor to do a very good job of it, which is what will come with the power distribution board that Multirotor Mania provided and sells, and is available for free shipping with the promo code BobaFettFPV. And then finally on this side, you have a ground. You have plus and minus 5 volts, and 5 volts only. It doesn't work on for some reason it doesn't quite work on the 12 volt. But I'm going to plug it up to the power distribution board anyway, so we'll talk about it more. And then finally, you also have video in and out for the OSD to be put onto the video feed. So basically what's happening is that this guy here is sitting between your camera and your VTX, and it processes in between, takes all of the variables that we're going to configure, put it onto that video feed, and then send it out through the VTX back to your goggles. So it's kind of doing a bunch of calculations on the fly on the board between you and the goggles, not adding any latency at all. So that's what we've got. So this is what we're going to be working on mostly, the MRM OSD. And in addition, we have a Dragonfly 32 from Multirotor Mania. It's similar to the Naze Rev 5 or Naze Rev 5. It has obviously 6 PWM ports. It's got 8 channels, all of the basics of a F1 flight controller. The Multirotor Mania has kind of confided in me that they are working on releasing a F3 board in the not so distant future, so keep an eye out for that. And that thing is going to be great. But I've been flying this actually for the last couple of days. It's doing a great job for me. I mean, all of the F1 boards are still good. You might want to be starting to think about F3 because of the features that are coming out in beta flight and other kind of similar firmwares like that. But F1 still kicks butt for a cheap price. We have an FTDI adapter. I've actually got... Where'd it go? 1 second. I've got one. Here it is. This is the FTDI adapter that Multirotor Mania sells. It comes naked, but you can get some right angle pin headers and put them in that, and it makes it really easy to work with, which we will talk about in a second. These are some servo leads. You're going to need 6 for FTDI for the FTDI adapter. I'll set those aside for now. This is a TS58 TS58400. It is the race band capable version of the... No, it is the TS normal boss cam thing, but with a push button for channels on it. So that's going to be pretty nice. We've got an HS1177 or the version that Multirotor Mania sells, just a cased 600 TVL Sony camera with a 2.8 millimeter lens. Okay, so what else do we got? So right here, and I'm just using this frame. We're not going to build a whole quad tonight. We're just going to work on the FPV system. But this is the power distribution board that Multirotor Mania provides. It has 5-volt regulator as well as a variable regulator. So you can set it to be you could set it to put out 12 volts or 8 volts or whatever you need, maybe for like your LEDs or something like that. And so right now I actually have it configured to put out 12. 16 megabytes of onboard memory will be on that F3 board, but they'll provide a bunch of more information soon. I was only asked to just say hello. So yeah, that's what we've got going on. Or not say hello, but to say that it's coming. Be ready, be prepared. Let's see. We have I've got an X4R receiver that I'm going to be combining with this so that we can kind of demonstrate some of the in-flight features of the power distribution board. And I think that's it. We've just got building supplies other than that. So the first thing that I'm going to do is actually start with the FTDI adapter, because you kind of have to do a little bit of setup to get everything ready for it. So you can buy from Multirotor Mania, or if you have them already, angled pin headers. And I'm using a set of 2 rows on this. And so we'll just solder them right in just like that. So we need 6 sets for this FTDI adapter. If I can find my scissors. So we'll just cut it right here. Comes apart nice and easy. And so the FTDI adapter actually has 2 rows on it. Both of them do the exact same thing. So you've got ground power, which is 5 volts, which I think you can change if you bridge a solder pad. Right here, you can switch it from 5 volts to 3 volts, TX, RX, and then DTR. So all we have to do is solder this guy right on here. If I could get it hot enough. I need a soldering iron that'll get hotter. What? I don't need to have frustration with this. Where are my helping hands? Oh boy. I cleaned my desk before starting the stream, which just means that all of my stuff is in places where I don't know where it is anymore. All right. Okay, so that'll help hold it a little bit steadier for us while we're trying to solder on these nice little pads. Come on. My hands are always jumpy when I start working on soldering, and then it kind of calms down over time. It's hilarious. No matter whether or not I'm on a stream, I get my hands just kind of shake a little bit when I first get started. So it always kind of cracks me up. How many amps can the PDB handle? Actually, that's a good question. I don't know the answer to that. But yeah, so here is the FTDI adapter all wired up. And then, so you want to have a couple servo leads handy. And you can just plug in to either set of rows, but make sure you use the same set for both. I like to kind of crisscross them so that you get the nice rainbow. Okay, now on the other end, we are going to put our MRM OSD. Now, what I found when I was building this is that because this is a little bit long, we want to make sure that we have room to we want to make sure that we have room to get the pin headers on and off really easily, because in order to flash this, you need to be able to connect to it via USB using this FTDI adapter. So I didn't direct solder it, which is contrary to normal, which is not what I would normally do, but it makes it a lot easier to connect. It makes it a lot easier to be able to get back in and out and flash it. So so this is a completed Multirotor Mania 225, the same frame that we're looking at over here. What I did, and I don't know if we're gonna be able to see this, is you can see that the let's see. You can see that the OSD is back here in the back, and there's actually a set of USB thingies, or not USB. What am I saying? There's a set of what are these called? ESC connectors. I can't remember the name of them, that are hooked up to the board, and you can slide them on and off really easily, and then slide on the FTDI adapter when you need to. So that's kind of how I've got that set up so that it's nice and convenient. But so what we're going to do is we're going to take a single set of right angle pins and point it back across the board so that you can still plug it in and it takes up less space. So if I grab my scissors again, 1, 2, 3, 4, 5, 6, and let's cut. And then, so this will fit on here, kind of facing backwards across the whole board. And we'll still be able to get the FTDI adapter on there. And then when we hook it up to the real quad, we only need 4 of the 6 connectors. So yeah, pretty cool. So I'm going to go ahead and solder this guy on. All right, so that should be nice and level. We'll still be able to get the servo leads on there. Okay, so now we have a assembled Minim OSD, and we can connect it one-to-one straight to the FTDI adapter using these servo leads. And then before you ever plug anything in, check for polarity, which I have backwards. Jeez. So on this side, you probably can't see it on the camera, but you have ground positive. And then on this side, looking at this diagram, which is this way, you have ground positive. And so that's this cable going across, and that polarity is correct. So, you just always want to make sure before you plug it in to 5 volts on the computer. So the first thing that we need to do is flash the Minim OSD with a firmware called Multirotor OSD. It's the gold standard for OSD firmware for these boards, and we're going to install the most recent version of that onto the board using this FTDI adapter. Let's see. In the link dump, I have put links to. Well, I gotta find my USB cable. I know I brought it down here. Aha, on the ground. I put into the link dump links to both the Arduino project, which you need their IDE to flash this, and links to the MW OSD, which is what you need to connect or to set up to flash the firmware that's going on the board. So I'll leave this here so you can see it. You can see that the LEDs came on and everything is connected. So I'm going to go over to the computer and switch over to my desktop view, which is always exciting looking, and jump over to an internet browser. Sorry, one second. Come on. And we're going to go to mwosd.com. And here you can come and look at the firmware. You can see that it supports CleanFlight, BetaFlight, BaseFlight, MultiWii, Harikari, Tile Labs, DJI, all of the things that you could ever run the firmware on. So I've already got it downloaded, so I'm not going to bother downloading it right now. And at the same time, you also need to get the Arduino IDE from the Arduino project website. And you can get that, right here. And so you just go and you download their software. I think it installs some drivers as well as an actual piece of software that you use called an IDE, which will handle the flashing for you. It's a little bit confusing for a first timer, especially if you've never worked with Arduino or are a programmer or anything like that, but I'll show you how to do it, and it's really not bad at all. So I have my MWOSD firmware downloaded here already. So you get a zip file, you open the zip file, and then you have sorry, let me check something here. Just want to make sure that this is coming through all right. Okay. You have two folders inside of that. One is MWOSD, which is the firmware. So if you're used to like flashing a naze, the naze.hex file is the firmware. In this case, the firmware is a set of folders that will be basically put onto the MinimOSD by the Arduino IDE. At the same time, you also have the MWOSD GUI, which is a software package that runs on your computer that will allow you to configure changes visually. So it's basically the version. It's basically the sorry, it is the equivalent of the CleanFlight configurator, which you see back here, but for MWOSD. So what we're going to start with is flashing the MWOSD, or sorry, we're going to flash MWOSD onto the MinimOSD piece of hardware. And to do that, all you have to do is double click on the MWOSD.ino, and that is the JRIPFPV. If you have the Arduino installed, then it is able to recognize the different types of file. The .ino is the Android or Arduino, IDE. It will know to do that. And then if you go in here, you can see a whole bunch of settings. There's all sorts of stuff, and you can read up a lot on all of these, what each of these means and what they're going to be doing. But for the most part, they can be changed in the GUI. There's only one thing that you need to do when you download it, is that you want to come in here and define your flight controller firmware. I'm going to be using BetaFlight. By default, I believe that it looks like this, and it's just centered on CleanFlight. Oops, sorry, I deleted one too many things. But you want to / CleanFlight, / BetaFlight, and that will allow you to use BetaFlight on the firmware, which all that really does, honestly, is add air mode text to the OSD. The rest is completely the same because it uses the same MSP, which stands for Multiwii serial protocol to communicate back and forth between the OSD and the flight controller, because the flight controller provides information to it, like if you want voltage, and like leveling information, gyro information, accelerometer information, all that stuff. But but all that to say, go in, make sure that you have your right firmware set. So I have it set to beta flight, so I'm saving it. And then if you have the FTDI connected, what you need to do this. You need to go up into Tools and find Board, and make sure that Arduino Pro or Pro Mini 5-volt 16 megahertz ATmega 328 is selected. So that's a bit of a mouthful to remember, but that is the type of communication, that is the type of board that we are flashing. I believe that the documentation says this somewhere. Newbie question: what's a GUI? A GUI stands for Graphics User Interface, and it just means instead of using like code to change things, you're clicking buttons to change things. Your computer is a GUI. So we're setting the right board, and then you want to make sure that you have your right serial port set, and that really just is like in CleanFlight when you choose the right port to flash to. You need to do the same here. So I've already done that. I've got my beta flight defined. I've got the right board defined. I've got the right port defined. And then all you have to do is click upload. And it's going to think for a while. And it's actually uploading the software to the OSD right now, getting it all ready to be connected to your flight controller. A serial port is in use. So what happened was that CleanFlight is open, and CleanFlight is taking over the slabbed USB to UART port. And I've done this 100 times. So just make sure that you have CleanFlight closed when you're trying to do it, because it's going to interfere with your ability to communicate. So come in here, click go, click upload, and it will think for a sec. Multirotor Mania asked me to warn about a particular error when you're using Windows, but I can't remember what it was. Multirotor Mania, can you remind me what it was that I was going to mention there? Thank you. Okay, so this is done. You can see done uploading, binary sketch, blah, 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 of maximum. Oh, yeah, that was the thing. It complains that you're using like 90% of the maximum, but you can just say okay, and it will go through, and it will be fine. So if you get an error message that says it's going to use more than 90%, just say okay, let it keep going, and it will be fine, because it uses almost all of the available memory, but not quite. So I'm going to go ahead and close out of this because I don't need it anymore. Okay, get some frame rate back, hopefully. And I'm going to switch back over to USB cam. Okay. So we have, let's connect to it through the GUI. I'm going to go back to the desktop. Woohoo, that's super exciting, isn't it? If we go over to the GUI and we skip into Mac OS X because we're using a Mac here, and run the MW OSD GUI, we'll be able to open it in a second. I'm just going to minimize that for a sec. And minimize that. Where's my GUI? There it is. And this is I apologize for the status of my desktop. I need to clean it up real bad, but I just don't have time to do it. So this is the MultiWii OSD GUI. The GUI is, like I said before, the equivalent of like the CleanFlight configurator, but this is the MultiWii configurator. Multirotormania.com says, if you're using the latest version of Arduino IDE, which is 1.6.8, you will get a memory warning. I do not have... Yeah, I know. I actually usually keep my desktop really clean, but when I'm like working on videos and at work and screenshots and all that stuff, it just gets like a flustercluck. So I just kind of go through and do a purge once in a while. So I apologize. I need to get it. But yeah, so I am using the version 1.0.6 of the Arduino IDE, which does not care about that memory issue. So that's why I didn't see any errors. But if you're running 1.6.8, you will get a memory warning. You can just click OK and go through. Don't worry about it. Okay, so this is the GUI. On the left side here, you've got COM settings, and this basically allows you to choose which port. So like before, we need the slab to USB ART port. and that will connect us to the OSD. So you can see that it's thinking, it's green now, and we have got a whole bunch of things. The first thing you need to do is upload a font. So come over here to the left side, find font tools, click select. And I always use default bold.mcm. So what happens is that when you flash the board, or when you so this is just saying it's loaded. So what happens when it comes out of the factory is that it does not have a font file in it. It does not know how to display text. And when you flash it and when you connect to it and you don't realize that, it kind of looks either jumbled or nothing there. So you want to come in and you want to say select font tools and then upload, and it will think for a second. You can see it's uploading 5, 7, 9 of 256. And that will get you all set to be able to connect to it and actually see stuff happening. All right, well, that's uploading. Let's look through some of these settings. So main voltage and video voltage. Like we were looking at on the chart, display voltage is main voltage is the actual flight battery, and video voltage is the FPV video battery. I want to have the FPV video battery off because I don't have one. I've only got a main flight battery. So I'm going to click display voltage, and I'm going to make sure that use FC main voltage is off, because I'm going to be using the actual MRM OSD to do the voltage calculations for me, not the flight controller. Same thing for amperage. We'll come back to this in a bit, but this is how you calculate milliamps used so that you know exactly how much of your battery you have depleted. Same thing for display RSSI. You want to use the RSSI on the MRM OSD, not on the flight controller. I can't demonstrate this tonight because I'm using an X4R, which does not have an RSSI port, but there is a way to do that using your flight controller and the Tyrannus. Over here, you have different things like I like to have display throttle position turned on, and it shows you just the percent of throttle that you're using at any given time. Not particularly useful when you're in flight, but when you land and you look at your video, your DVR, you can then see like, oh, I was at 100% throttle there during that exciting maneuver or whatever. So I like to leave that one on. I like to have display flight mode on so that it shows me whether I'm in horizon, acro, whatever. I'm almost always in acro air mode, so that doesn't matter. I turn off FM sensors, which is how many satellites, I think. Display gimbal, we don't need. Display vario, we don't need. Display baro alt, we don't need. And I leave the timer on. Basically, that will count up whenever you're giving it throttle input. And so that means you know exactly how long you've been applying throttle and how long you've been in the air and not just sitting somewhere. So I leave that timer on. I don't like the horizon bar because it just kind of gets in the way of everything. And that also turns off the sidebars and SB scrolling. I'm also not flying with a GPS, so I can turn that off. And I don't have a compass, so I can turn that off. And so now we kind of have this very MRM OSD that has your your battery voltage, a timer, throttle percent, and mode. And now everything is just kind of nice and out of the way. And if I could remember where it is, you can actually, where is it? Sorry. You can set a call sign down here to flash every like 60 seconds or something. And that will do something. I'm losing place. There's a way to move stuff around on the OSD and I cannot see it right now. What in the world? Anyway, so we have configured all our settings. We have it exactly the way we want. So all you have to do is come down here and say write. And that's going to take all of the settings that you've set, upload them to the modified RC says the flight timer is not flight time, it's powered on time. It's actually both. It will count up while you are sitting on the ground so you know how long it's been on. And it will also, when you're in flight, when you're armed, it will also count your throttle time. Layout editor, there it is. Okay, thank you, modified RC. So if you come in here, you can scroll through these things, which are each of the individual items that will display on the FPV or on the OSD overlay. And the thing we need to get to is the throttle, because I want to move it a little bit to the right so that it's kind of more lined up with that stuff over there. So I'm just kind of clicking through until I find the slider or timer or throttle percent. And I must have missed it. That's pretty bad. Voltage, temperature, RSSI, longitude, latitude, roll angle, pitch angle, arm status, timer, unused, throttle. There it is. Okay, so throttle. And then you can use these little buttons over here to move it around however you want. So I'm just going to move it kind of over there, and I'll give it a little space above. So now most of my OSD is nothing. I'm just seeing the video feed, and it's not getting in my way. I can glance down here to see my voltage, and I can glance down here to see how long I've been in the air. It's clean. It's easy. There's none of this extra crap in the way, and it's going to allow us to kind of make better calculations on our flight so that we don't get in the so it doesn't get in the way of everything. So I'm going to write this again because I moved that thing around, and that will flash the OSD to the multi-way OSD. Okay. Now we can go back to building OBS and to USB cam. Okay. Sorry. Let me migrate my thing. Trauma Factor says, Paul, I made it. Hi. Welcome, Trauma Factor. I apologize again for the desktop. I'm really sorry about that. It's pretty bad. I'm a pretty organized person. But for whatever reason, I can't keep my desktop straight sometimes. Okay. So I'm going to pull that out. And now we are ready to start hooking things up. Hooking random stuff together. Let me find a servo lead here. I don't want to use that one. I've got a few. Okay, there's one, and then oh wait, that's a female. So I'm looking for a couple extra servo leads. Which I will use to connect the Minim to my flight controller. So we can actually get rid of that for a little bit. So we need only 4 to connect to between the OSD and the flight controller. So we need 1 over here, and then we will just need 1 right there. Now I don't want this extra stuff in here, so I'm actually going to just take a pair of angle clip cutters to this servo header to just kind of cut it all apart, because I don't have crimping tools and all that stuff. So you're about to see something that probably could be done a better way, but it's just the way I do it. So it's a good way to waste a servo cable, but it gets the job done. And I am all about getting the job done. Okay. Now you can just cut right off here. And now we have, I should have used a different color. Oh well. Because now it's going to get a little confusing to have both colors right next to each other. And so now all I do usually with this, is just electrical tape them together. Nice and easy so that they stay together. Let's see. Anybody have any questions? Can you make the voltage flash or change colors at a set point to grab my attention? You can configure that. So that's what a chew asks. You can configure when it will flash a big low voltage alarm to the OSD so that you see when you have gotten below a certain threshold. So I think I have mine set to like 3.8 or something. So when the voltage gets below a certain point, it will just blap up on the screen, low voltage, and that's when you should be thinking about coming into land. And so that's just the way I have it configured, and I think is a fairly common way. And I put that on the wrong side. Oh well. Okay, so now we have a 4-pin servo lead, which will connect to the 4 pins of the OSD like that, and that's all you need to connect it up to the flight controller. So now if we go look at our flight controller, let's zoom this in again a bit. Where's my wiring diagram? Okay, so this one, for some reason this print came out like it's 3D, so it's really hard to see, but over, I need something to point with. But you'll also able to look at this on the internet with a full, much better display. You can see that this says OSD/Bluetooth right there, and then right here is the ground 5-volt TX and RX. So we need to hook up to that row. This side is the ground. This is the positive RX TX, and so we're going to prepare this wire a little bit. Actually, I want to make sure that we've got the proper lengths here. So my plan is to put the flight controller on like this sideways so that I can reach that USB port. Where is my pointing tool? So I can reach that USB port, and then according to the wiring diagram, these are the ports across the side that connect to the OSD. And then over here, so then I need to run. So then what I'm going to do is I'm basically going to put the OSD kind of on the back here. Actually, that's the front. Let me turn this around. You can see the little camera mounting points right here. So with this side, the back, I'm going to put the OSD on the back here, about there, and I'm going to run this USB port, or not, gosh, I keep saying USB, servo lead all the way to the end. So I'm going to run it basically like that. So now I know I need to cut the wires right about here. Okay, get this stuff out of the way, and now we can prepare this to be attached. So I'm going to strip off a little bit of wire. I'm going to raise you up a little bit here so I don't have a little bit more room to work with. Strip these apart. Okay, so we've got those taken apart, and then I'm going to tin them so that they're easier to solder onto the flight controller. Okay, so that's ready. I like to have these wires nice and short. It makes it a lot easier to direct solder to the flight controller, in my opinion. So I always just kind of trim off a little bit of extra length, and it just makes it a little bit nicer, a little bit cleaner when you direct solder to the flight controller. So those are all nice and short like that, and that's going to go onto the flight controller much better. Okay, so I'm going to pull this off, and I'm actually going to do it upside down so that the wires are all hidden out the bottom. I like it when my flight controller has 0 to a few pin headers or wires coming out of the top. So we got ground on this side and the other RX on the far. So this should be ground, positive, RX, TX. So we've got to tin this up too. Once again, ground, 5 volt, RX, TX. Okay, so that's that. All right, one more time. Ground, positive, RX, TX. Just always make sure that we're double checking everything. So I'm going to use the red one as positive because that's the only one that actually makes sense based on how I cut my cord, unfortunately. But you know what? That's okay. I'll remember. I only have to do it once. I find that tweezers make this a lot easier. So if you don't have any, just go on Amazon, get a nice set for like $10. And so there we go. That's the positive. And we'll attach the ground right next to it. And then I got to double check that we got the TX and RX right. Okay, so this is something that I learned yesterday the hard way, is that so when you're wiring this, where's a pen? You know what? Give me 30 seconds. I'll be right back. And I'm back. Excuse me. All right. So this is, we have positive, negative, TX. Wait, is it TX? No. Actually, I screwed that up already. We have ground, positive, RX, TX. Okay, this is the flight controller. I use the same color for 2 of them. Okay. Okay, and then on the OSD, in a particular order, we have positive, ground, RX, TX. And this is the OSD here. Okay, so we need these. Let's use another color here. We need these 2 to connect, obviously, these 2 connect, but then we actually need to cross connect our RX and TX. I guess I should have done that upside down. So you can, so you need to have these go straight, and then you need to cross them. So that we need to pay attention to that when we hook this up. Sorry, let me get these out of my way. Arts and crafts is over, kids, and we're back to our regularly scheduled programming. Okay. Now, so I'm just going to plug this in right away. Nothing's powered, so it's going to be fine. We've got ground, positive, and then we need to cross the last 2. So I'm going to hook TX to RX here. And then RX to TX here. I think I actually said those backwards, but the point stands. Okay. So now that guy will be ready to, the flight controller will provide power. No. Yes, the flight controller will power this with the 5 volts, and it will communicate with the other 2 TX and RX. So when we put this onto our airframe, we'll essentially get something like this, where we can then take on and off that USB port. I guess you can't see that at all. You can take this FTDI connection on and off really easily without ever having to take this whole thing apart. And then, between then, you can come in with your FTDI adapter and plug all 6 in. So it works pretty well. That's a great way. But yeah, so I'm going to mount my OSD on there so that it's kind of held in place. And my favorite tool for that job is Velcro. It's cheap stuff. It works for a lot of things, and you can take things on and off really, really easily. So then those of you that have been around know that I really like using Velcro, and so I'm going to continue to carry on that legacy. So I can put a big strip of... Oopsie. That was weird. My bad. So I'm going to put a big strip of Velcro right here out the back. And I did it again. Dang it. Sorry, I bumped the keyboard that's over here with the scissors. Okay, so I'm going to take this Velcro, get that off of there, and I'm literally just going to lay this piece down across the back. Make sure not to cover up the mounting points for your thing. You can use this for you can use this method for any kind of hardware on there. I'm going to use it for this, and then all I need is a piece of male Velcro, which will also go on the Minim. Just on the back here. Now that'll be held nice and secure in place. And when we put the flight controller on, hook it up. Now that's all ready to go. Everything's out of the way. It's not going anywhere, and we're set. Looks pretty stinking sweet. But yeah, so now that's all hooked up. We can take that on and off, and that's just a great way to do it. Okay, so we need to continue to wire the OSD to the power distribution board. I'm gonna take that out for now. We'll come back to that maybe. 1 second. Okay, so the first thing I want to do is actually double check the settings on the power distribution board. No, I don't. I don't need to do that. I remember. Okay, so this is going to receive power again from the flight controller. The flight controller is going to provide it 5 volts. And then this is going to, the only thing that we need to connect to it right now is the LiPo voltage. We'll come back for the other things in a bit. It's not whiskey. Actually, tonight it's orange juice. I didn't have time to make tea, so I just pulled some orange juice out of the fridge. I wish it was whiskey. I can't do that in live stream at the same time. So what we're going to do is connect the main battery line directly to LiPo power out from the power distribution board. And this port right here will be good enough for that. You will also connect some ESCs to that later when you're working on this, but you can always put multiple things on the same pad. It's not going to cause a problem. So I've got some extra wire over here. Now, if we look at the Minim OSD, let me move this down a little bit. We have across the side we have FPV, main battery, RSSI, and current sensor. So what we want to do is skip in 3 holes. So 1, 2, 3, and then we have main battery positive. So 1, 2, 3, that's going to be the main battery. 4 is going to be ground. So we're going to put positive on 3 and ground on 4. So really all we're going to do is run this wire from 3 to positive input on the power distribution board. So let me cut this wire. I feel like I cut that short, but I think I'm good. 1, 2, 3 to the LiPo. Okay, so that's good. So I'm gonna strip this guy down again. Tin this up. And then I'm going to tin the pads here. So like we said, 1, 2, 3 is the positive. And 4 is the ground. And we can tin this pad here. And it's hard to see, but this side is the positive, this side is the negative. We can double check that polarity before we do anything by plugging in a LiPo and using a multimeter. Got positive on this side, ground on this side, and we're getting 11.4 volts from the battery. I don't know if you can see that very well, but we have the polarity right, and we can just make sure that everything is good to go. Okay, so where's our positive line? Once again, tweezers make this a little bit easier because these are pretty tiny little ports. Put that up there, and then run this right to our positive line. And voila, nice, clean, positive LiPo battery to 1, 2, 3, third port. Now we need to do our ground side. Let's see if this wire is long enough. It's cut already. That's a little short. Let's see. All right. Nope, I don't want that one. I want the black one. Might as well use the right colors while we can. So that to that. Cut the wire right where we estimated. I think I cut that a little bit long this time. That's okay. Better long than short. Okay. Tin this wire up too. Need my tweezers. Okay, ground installed. Now we'll put it to the, that's long. I'm gonna cut that. I want it to be nice and clean. Tin it again. And voila. Okay, so now we actually have everything wired that we need to run this OSD. So the flight controller has the FTDI port, which is going to just run straight in like this. If I can get it. We got the polarity right there. And then we have a LiPo voltage monitoring cable that is hooked up over on this side. So we've got a whole OSD system wired up, clean, easy. It's out of the way, and it fits perfectly inside of this particular frame, which is the Multirotor Mania 225. But yeah, this is a great setup. The next thing we need to do is run 5 volts from the power distribution board to the flight controller. And on this power distribution board, we have 5 volt out right here. Let's double check that. So that's not powering up because it's not powered off of that. That's just a VBAT monitoring. But if we check this right here, this should be ground and this should be 5 volt. And it's about 5.3, which is just fine for our needs. Okay, so to power the Dragonfly 32, what we want to do is run 5 volt from the power distribution board to any motor mounting point, and these are motors. This is 1, this is 6, and we're going to put it to ground to volt. So if we take it from here to there, that's going to be exactly what we need. So I'm going to get some more wiring here. I'm going to leave it a little bit long on purpose so that I can take the cable on or take the board on and off, and still have some room to work with, because I'm going to have to come back and add my ESCs and my motors and stuff later. So I'm just trimming these wires. Okay, and tinning. Okay, those wires are tinned. We're going to start by putting them on the power distribution board on VCC 5 and ground. Okay, this is positive. And this is ground. Okay. Now for the flight controller. We want to hook it up, like we said, to motor 6, which is this one. So if we flip it over, it's now the outside 2. I like to just put it right on here like this. That'll hold it in place for me. Was the discount code presented yet? I got yelled at by the wife. The discount code is Bulbuffet FPV. This, tin that one, tin that one. Now, if we look at this again from the other side, ground is on the outside and volt VN is on the inside. So we want to put ground to, or let's start with the power one because it's going to be easier to reach the ground one after the fact. Actually, I want this to come inside like this because that's going to become the outside. Oop, slipped a little bit. Okay. And then same thing here. Okay. So now the naze has power. We've got our polarity right. Let's see. Ground, voltage, good to go. We've got FTDI ready for the OSD. So let's run this all together. Well, let's first just power up the flight controller so that we cut our losses if we got something totally screwed up, which you never know. So we should see the naze power up, light up. and no magic smoke. Look at that. Whew. So now if we plug in the OSD to the nays, down here, we should now see LEDs pop on this, as well as on the, I keep calling this a nays, I'm sorry, it's a Dragonfly 32. Now we plug these both together, and voila, we got LEDs there, we've got LEDs there, and there is a communication port active down here. I don't know if you can see the flashing green light. But yeah, so that's working OSD system. Obviously, we don't have any FPV yet, so we're gonna have to do that step next. All right. So I left that long intentionally so that I can still get under there, because it's kind of a pain to not work underneath it. But yeah, sorry, Dragonfly 32, not a naze. My bad. Okay. Next step. We need to hook up the FPV system. Where is my camera? We need that, and we need this. So this is HS 1177. I don't know, can I call it that? Is it an HS 1177? I'm so glad I didn't hear that. Oh man. Okay. So this wire does three things. It connects to the camera here. So we've got this one goes like this. So we're going to power the camera off of these 5 volts, and then we've got to run the cable back to these ports back here, the video cable, because that is going to be the video out from the OSD that puts the signal onto the or the video in, sorry. And that's going to take the signal from the camera, convert it, add the OSD, and then send it back out to the VTX. So we're going to start cutting these to length. I'm going to leave a little bit extra because I don't have the mounting hardware on here yet. But so I'm going to cut this about, I'm going to cut these guys about there. And I'm going to cut the video one a little bit longer because it needs to reach all the way back about there. I cut those positive and negative really long. So that should be just about the right amount of room. I might have to recut that or redo that later, but for the purposes of the stream, it should work great. These cables are a little bit on the small side for any of the strippers on my wire strippers, so I just have to do it kind of manually. Paul, you want vid signal and ground to go to the OSD. Send only power to the adjustable BEC output. So you're saying so this is the adjustable output over here, which I have currently set to 12 volts. So you want me to run the, V out. No, so you want me to run the power to here and then the video straight to the OSD? I think that's what you're saying. So instead of what I was saying, we're going to power it off of these ports back here, and the video goes straight to the OSD. Yes, and send the camera and VTX power to there. Ground and signal go to OSD. Oh, you want to do the ground on the OSD itself. Oops, I cut that cord a little short for that. Okay, well, for the purposes of this, I'm gonna just do the thing. So what we're gonna send ground and signal to OSD, voltage, power to here. Okay, so we are just going to use power right off of this. Actually, let me double check the voltage on that. Okay, everything's clear. Powering up. And then this should be regulating to about 12 volts, but because I'm using a 3-cell that's undercharged, yeah, we're getting 10 volts, but that's fine. Camera ground does not go to OSD, then camera image can disappear. Okay. All right. Here we go. Okay. So I'm taking the power of the camera to voltage out on the power distribution board, which on a 4-cell will be about 12 volts. And that's going to be filtered power. Now, on the OSD, we have, let me see if I can show you this. We have ground on the most inside pin. So these guys here are going to be ground. And then we have video in on the inside video pin, which is there. And then we have video out on the outermost pin. So what we're going to do, so we can move this out of the way, is tin up some pads. Ground, ground, video in. Sorry, it's a little cramped in here. And video out. Okay. Now, this video in is going to go to that back point, and this ground is going to go to either one of those because they're the same. But I'm going to mirror them. So if we go here, yeah. There's the video and the ground for this whole thing. Okay, so now we have the camera wired up, ready to go. I'm going to move these wires out of the way so we can get our VTX in here now. I'm just moving these wires up and out of the way so that when I go for the VTX, it's a little easier. Where is my VTX? Here it is. So like I said before, this is the VTX we're using. I'm just leaving that antenna on there for now so I don't forget. I gotta find the cable that came with it. Which is here somewhere. There it is. All right. So we've got ground on the top, 7 to 24 volts on the bottom. There's also audio and all of that shenanigans, but this doesn't have a, oh, I gotta cut away some heat shrink. Okay. And that's backwards, like this. All right, so we've got that wired up like that. I'm gonna go ahead and just leave these long for now, and some of them, some extra ones connected, so I'll come back and clean it up later on my own time. All right. So these three are the one we need right now. We need 7 to 24 volts in, ground, and video. So we're going to put the positive or the video or the power in from this pad here, which is another voltage out pad from the the regulated voltage from this power distribution board, and then we're going to hook the video up to that video pad and the ground up to that ground pad. Okay. Start with the power. Like I said, this isn't pretty right now. When I actually build this, it will become much, much better to look at. Okay. There's that. Ground goes to there. And video to there. All right. So, with any luck, we'll actually have all of this wired up right now. I'm going to grab these extra wires here and make sure that they aren't going to make anything explode. So there's 5 wires. Okay, so like I said before, a little bit messy, unfortunately, but that's okay. It will all be cleaned up later. This is for the point of demonstrating how an OSD wiring system all works. Okay. Ugh, I hate powering stuff up. All right, so we have VTX. We've got power to power, ground to ground, and video to video out. Let me make sure that's video out. I'm 99% sure it is, but it's always worth double checking. Video out is on the outside, and that is the outside, so we're good there. And then for the camera, we have video in on the inside. We've got ground, and we've got power. All right. I'm going to go ahead and drop this on top of all of that. Looks a little better once you get that in there. And that's powered, and that's connected to the OSD. So now we will have the opportunity. I'm just going to lock this guy down on here so it doesn't bug me. I'm not actually going to use these standoffs. They're easier to put on than the nuts. So now we've got so we've got, what in the world? Oh, we got a wire pinched in here. Get out of there. There we go. That's better. Okay, sorry, that was going to drive me crazy. Everything's wired up. We've checked the connections to make sure that there aren't any potential shorts or mixed polarity. But we've got VTX, camera, OSD, and NAS all connected together. So with any luck, we'll have magic smoke in 5, 4, 3, 2, 1. No magic smoke. And the VTX did power, so that's good. And the there's no way to tell with the camera because I don't have LEDs, and everything else came on, so that's a good sign. Now I got to get my screen hooked up here real quick. Give me a second. I don't have a way of sending video signal into the computer, unfortunately. But you know what? This is good enough for now. Oh, jeez. Well, I guess if I can find a different connector. Where is it? This would be annoying. I thought I had this all set up. My RCA plugs don't want to come up. There we go. Okay. Brilliant. Got an adapter here somewhere. Everybody take a break. Okay, here's the cable I need. Sorry, my ground station wasn't as put together as I thought it was. That one. And this one. And power and on. Oh, I need another battery. Sorry, 1 minute. Almost there. Okay. All right, I'm going to power this on again with the VTX on. And I'm going to scan. And wrong channel. We got it. Okay. Let me see if I can get this in front of the camera. All right. All right. So we see right there that we now have 10.5 volts, which is correct. Actually, that battery is really low and I need to charge it. And this is a, you can see that there's no data. That's interesting. It should be getting data. Maybe we have something backwards. We have no data, which we'll figure out in a second. And then we also have the on timer and a throttle setup. So yeah, so that's, I mean, it's working. We have voltage, we have everything. So we're well on the way. All right. What did we do wrong here? Why do we have no data? So we're going to take the nays off here. Ah, that's probably why. That cable came out entirely. That's funny. You guys see that? This one popped right off. Probably when I was trying to fix that wiring. All right, I gotta put that on top apparently. So be gentle with your wires. I made a stupid mistake. Ugh, that's so much. Get out of there. Okay, there we go. Unfortunately, that ruined a little bit of the cleanliness of my build, but that's okay. Yeah, I was manhandling it. That was stupid on my part. Okay. So there we go. Everything's wired back up. Go ahead and power this on again. Let me make sure. Wait, no, I don't trust myself all of a sudden. No, that's right. Yeah, we're good. Did I say nays again? Damn it. I gotta stop doing that. Nays is like generic for flight controller for me. It's kind of bad. All right, let's power this back up. Let's power this bad boy back up. All right, go. So camera's on, VTX is on, OSD is on, and hopefully all cables are connected this time. All right. Yes. Okay, that looks better. I need a better way to do this. One second. I'm going to make this a little bit easier on myself. Okay. There we go. Aha, okay. So now we can see still that we have voltage enabled. We have disarmed status, and we have my screen just went dead. And we have the flight timer counter going, so we can see clearly that this is working, and that we're seeing stuff from our stuff. We also are in acro mode because there are no modes, because I've not flashed this flight controller. There's no modes set, and every time he says nays, take a damn it, still doing that. This is a family friendly show. Hi, puppy. So we've got all that connected. We're good to go. The camera is working. Hi. This is confusing. And yeah, so that's good. All right. How do we want to do this now? Okay. So I'm going to power this down for a bit. And what we can do is actually use the GUI to simulate how the OSD would behave in flight. So what I'm doing is I'm taking out this guy from the flight controller, and I'm going to plug in the FTDI adapter back into the OSD and connect it directly to the computer instead of to the nays, to the flight controller. God dang it. Okay, that's connected. I'm running this to the computer. I am going to switch us back over to desktop mode, which is always exciting. I go back into the GUI, and we can see that we're already connected, actually. Let me minimize this so that's out of the way. Back to the messy, messy desktop. All right, and then I also want you to be able to see the screen. Shoot, but now I can't see if you can see it. All right. Can we see that all right? Nope, not at all. There we go. Okay. GUI. All right, so on the GUI, we have this button called Simulate OSD. And what that actually does is say, now this computer is in control of the OSD, and we can tell it to do whatever we want. And it can basically fake what would happen as a flight controller. So I'm going to power up everything so that we have... So we can see the OSD. Oh, that's looking right at me. That's great. You know what? My RX battery is dead. I gotta find another 3-cell real quick. Take a break for a quick message from our sponsor. Okay. 3-cell power on. All right. There we go. Back to our regularly scheduled programming. We're getting a little flickering because I'm using a rubber ducky that's like sitting here on the ground instead of anything decent. Okay. OSD. Powered on. Not getting data. Not getting data. Should be getting data. Let me restart the comm interface. There we go. Okay, so now we're connected. I reset the comm port so that we would get it. Okay, so now we're not getting the no data message because we are directly connected to the computer, which I'm turning on simulation mode, which is going to allow me to pretend to send signals to it. So like if, for example, we were to click ARM, we can see that the quad is now armed. Sorry, let me... And that we have low volts because we're expecting it to be a 4-cell. You can see over here that it says battery cells 4, voltage alarm at 13.8, and we are currently at, how many volts? 10.5 volts. And one thing that we can even do is actually go over here and change the amount of volts that maybe not. Thought maybe we could do that. But we could, for example, increase throttle. And you can see that the throttle percentage is going up on the OSD. And our throttle timer has started. And, you know, so you can kind of play around with those settings to make sure that everything's working all right. We can change modes. You know, we can turn on, like, angle mode. And so now we've switched over from horizon to stability. And we can turn off horizon and angle mode, and we would go into acro mode. And if my computer would behave, we could switch air mode on, and now we have air mode. So I mean, there's some really nice features with the GUI that you can play with. And now we're pretty much ready to hook all of the rest of the electronics up and go fly this bad boy. So yeah, I think we're pretty close to finishing up. I'm not sure if we're going to go through the current sensing right now, but I'm going to be releasing a video or two about this setup and configuration. Actually, it might end up being a series because there's a lot of stuff here, obviously. But I can cut a lot of it down and make it go a little bit more quickly. But yeah, so you are now ready to fly your quad with your OSD all hooked up. We're going to power this down for a sec. And once again, we can just pull out the FTDI adapter, put in the one from the Dragonfly 32, power this bad boy back up, and voila, we're now connected to the to the OSD and flight controller, like that. What HUD heads-up display are you going to be using? I use the 250 Racer HUD preset when I was using MultiRotor OSD. I did not use any presets. I kind of just configured it myself based on what I thought I would be interested in having. And that was really just voltage, timer, and throttle percentage, because that's kind of interesting when you go back and look at the DVR. So yeah, so I think I'm going to start wrapping this up, and you can look forward to some more videos. Excuse me. Sorry, let me switch over to sponsor. There we go. Okay, so that's kind of the basics of how to take a and if anybody has any questions, ask them now, and I'll kind of answer them as I go here. But yeah, so that's the basics of setting up an OSD. Once again, we did this with the MRM OSD, but you could also use a micro MRM OSD, which accomplishes all of the same goals as this thing, but in the smaller form factor. But on this particular quad, it suits it really well. For example, over here, this is a fully built, ready to go one, which you can't see, and I've actually got the OSD kind of down in there in the same fashion. But yeah, so you've got that. You've got the FTDI adapter. You've got the camera, flight controller, power distribution board. All of this stuff came from Multirotor Mania. .com. You can use the coupon code BulbaFedFPV for free shipping on any order that includes OSD equipment. So if you need an FTDI adapter or a OSD, or I don't know, maybe a camera, I don't know, and that will get you free shipping on all of that stuff. So you should go take advantage of that while you can. But yeah, like I said, this is super simple to set up. One thing I was going to talk about, we were talking about, so I've always said no OSD is the best OSD. And I think a lot of that was kind of came out of not fully understanding the process. So like I kind of didn't really know exactly how to do it. And so I was kind of just like, screw it. I don't want to go through all of that work. But this is a Dragonfly 32. But now that I kind of know how to do it and know that it's actually fairly simple, and have done it a couple times, I'm actually really starting to fall in love with the OSD. For example, actually, let me set up my other quad here. So this is my fully built, sorry, let me switch it over to USB cam. So this is my fully built Multirotor Mania 225. This is some of my own personal electronics, so it's not all MRM stuff, but the next build video will actually feature a lot of that equipment. So I'm just setting this here for now. I do use wax in my beard. Somebody asked that. I do not have any in it today, actually. Okay. So I'm going to power up this quad, which has an antenna, and scan for the right channel. I don't think my thing has race band, so we might have a little trouble here. And I have cross polarized antennas. Hello. One second. Okay, I think I have to switch this to a different band. Scan again. There we go. Okay, you can get this Yi mount from Multirotor Mania. It's made out of TPU. This one is specifically for the Multirotor Mania 225, which is an awesome frame. I am super excited about it, actually, but I'm going to be talking about it a lot more later. But yeah, so you can buy this at Multirotor Mania. This has it mounts straight onto the frame, so it's actually part of the structure. So this thing will not come off. It's made out of TPU, so it's like super flexible, but it also grips really well. So like as soon as I wedge my Xiaomi down in there, it holds on. And then this is a little 3D printed faceplate that I made that sits on here like that. And then I actually modified my version of this 3D printed TPU mount to have the strap on the other side so that it would wrap over and hold on to my Yi. Nice and snug. So I never worry about this coming out ever because it's just perfect. I love it. I have never liked a HD camera mounting system as much as this one. So I am super excited about that. Okay, so you can see that. Let me grab my Tyrannus so that I can show you some cool features of Multirotor OSD. Okay, I just have to remember not to arm this. Okay, so now I'm connected to the OSD. Let me tilt this up a little bit more. We see that all right? Okay, so the coolest thing, I think, in my opinion, is that the OSD allows you to take control using stick commands. So if I take my Tyrannus and do with the throttle stick full center right and push up, it enters PID tuning mode or configuration mode. And so what you can do, oops, that was the wrong way. I'll go this way. So what you can do is actually go through your PIDs. God damn it. Okay, screw that. Just turn it off. How's that? Okay. You can go through your PIDs and actually make changes here. So I can use this to jump up here, say I want to increase D a little bit, and I can just knock it over, a couple points. And that's going to allow me to make changes to that setting. Actually, I don't want to make that change, though. I'll do that. You're getting a lot of video breakup because I have a left-hand polarized antenna on here. And so now, but also, beyond that, you can kind of come in and say, let's go to the next page. And now you can change your RC rate or your RC expo, roll rate, pitch rate, yaw rate, change your TPA, throttle mid, expo, and all of that stuff. You can go to the next page, and now you can see you can change actual OSD settings. So like adjust voltage, for example, is something that you need to do to make sure that your so that you can make sure that you have the right voltage displaying. So like when I plug in a 4-cell battery, I was seeing 15.6 volts, which is way too low. So I just fiddled with that until it showed the right voltage on there. We go to the next page, you can see, display RSSI and all that stuff. Like just, these are a lot of the same settings that you would see in the configurator, and some more, horizon bars and all of this stuff. So like you are able to change literally, not literally, most everything through here, just using your Tyrannus. So when I'm tuning this, I literally just sit down on my flight chair and plug in the quad, make a couple tweaks to the PIDs, save, take off, fly it around a little bit, come back, don't even take off my goggles, use the stick command, get back into the OSD, make things. That feature is so ridiculously nice as someone that kind of flies a lot of different quads at different times, whether I'm, like tuning something of my own or helping someone else tune something, or working on a live stream build or something like that. Being able to just tune stuff up like that on the fly, fuck, that was what I was trying to avoid. Being able to tune stuff up on the fly is exactly the kind of feature that appeals to me. So when I've talked about no OSD being the best OSD, it was kind of a little bit out of ignorance, because I didn't realize how awesome a feature being able to change your settings on the fly is. because you can so quickly tune and go through stuff and change settings and try different things and have that data then again available on the have that data now available when you go back and look at your DVR. And I always am recording with the DVR, so it's super nice to this is why you remove props. I knew that was stupid, but I risked it anyway. I just accidentally hit the arm button. It makes for good TV, right? So all that to say, OSD is great, but it is also another failure point. So I kind of have this give and take of like, I really like the features of this, but it's extra work, it's extra maintenance, it's something that can go wrong. So it's kind of like this just awkward situation of like, I know what I do and don't like at the same time. So because I am becoming a slightly better builder over time, as I've become more experienced, I'm starting to become a bigger and bigger fan of OSDs because they give me features more than they give me trouble. So that's just kind of where I am at right now in my FPV career, and that's kind of just the way that I have been thinking about it lately. So you can take that however you want, but I am loving having an OSD. So if it's something that you're willing to risk in terms of a failure point, the features completely outweigh it. It's fantastic. But so that is the FPV live stream sponsored by Multirotor Mania. Once again, for the next 24 hours or so, if you enter the code BULBUFET FPV, BULBUFET FPV at Multirotor Mania on checkout, you will get free shipping to the United States on any OSD related component. So an OSD, an FTDI adapter. I'm sure they might even consider it for like a VTX or a camera or something like that. So this is a fantastic opportunity for a fantastic company that you should take advantage of. That being said, I've been kind of chatting with Multirotor Mania to do this stream and do these next couple of videos with them, and they just seem fantastic. Like amazing customer service. I have a couple frames now that I didn't have before that I am super excited about. One of the MRM 225 is going to be my daily flyer. I think it's light, but it's also strong, and I'm super excited about it. But so in 2 weeks, we are going to be meeting up again with Multirotor Mania, and we're going to be doing a full Multirotor Mania 225 build and test hover. And that is going to include the OSD. It's going to have all Multirotor Mania parts, and it's going to be awesome. So you should come out in 2 weeks to come check it out. In the meantime, thank you for your support, patronage, and subscription. Go buy stuff from Multirotor Mania because they're a fantastic company that we should support. And I am super... The free shipping is standard shipping. The priority shipping is extra. So, that should suffice. Once again, in the next 24 hours, feel free to place an order with that promo code for free standard shipping. Thank you so much, everybody. Have a fantastic night. I cannot wait to talk to you again on Thursday night next week, where we're going to be building a Apollo 2 from Atmospheric Adventures. It's a 3-inch quad that's kind of like the Butters from totally blanking. Shendrones. So can't wait to let you guys check that out. In the meantime, go buy Multirotor Mania stuff and stay flying. Thanks and have a great night.